Hey guys, so coming back from our introduction to vectors, I want to talk about the components of vectors and how we can break our vector down into two different parts. So the vector components, a vector can be broken into its horizontal and vertical components. So in this case, we can have a horizontal component that goes across like this. So if our vector is vector v, this could be our horizontal component, which is x, and we also have a vertical component, which is y. So we can break that vector v, or the vector that we have, into a horizontal part and a vertical part. Now, you're probably thinking, hey, Jen, that looks very much like a right triangle. And you are absolutely correct. It is. This is our degree that we're going to do it with. And so this starts to look like some of our primary trig ratio problems where we had 90 degrees in the corner. So we're kind of really coming back to that trigonometry stuff. Another way you can work this out is with the Pythagorean theorem. So we can come back to that. And I'll just remind you that in this case, vector v, or the magnitude of v, is equal to the magnitude of x squared plus y vector squared, the magnitude of them, and the square root of it. So we're still going to do the Pythagorean theorem to kind of find some of those things, or we can use the Pythagorean theorem to find out what those components are. We can also use trigonometry. So the magnitude of the horizontal and vertical components can be calculated using trig ratios. So sine of theta is going to be the magnitude of y, or the length of y, divided by the length of our vector. And cos is going to be the magnitude of x, or the length of x, divided by the magnitude of our vector v. This means that we can use this to kind of, if we know the angle, we can find some of these lengths by just using either the Pythagorean theorem or the trigonometric ratios. So let's see how this really works with an example, because I find it's a little bit hard to understand unless we do an example. So a train is traveling at 200 kilometers an hour in direction north 55 east. So again, when we're doing problems, I like to kind of highlight what's important. So the 200 kilometers per hour and the direction, super important. So we have our magnitude, 200 kilometers per hour, and we have our direction, north 55 east. So we're dealing with a vector. Let's draw a diagram of the velocity vector and its perpendicular components. So we have, I put the compass here, so north, east, south, and west. We're going to go north 55 east, which means we're going to start from north and it's going to go this way, and this is going to be 55 degrees. So, and this is going to be 200 kilometers per hour. The first thing we're going to do is break it into its perpendicular components, so it's horizontal and vertical components. Now, typically when we draw this, we are going to draw it like this, and we'll have our horizontal this way. So here is our x, and here is our y. In order to solve this, though, we're going to need to know what this angle is. And that's pretty easy to find out. We'll just find out what theta is by doing 90 minus 55, which gives us an angle of 35 degrees. So to finish off part B, we're going to determine the magnitude of the horizontal and the vertical components to 1 decimal place. So I'm going to start with the horizontal. So we're going to find out what x is. Now, if we use the formula up here, cos theta, sorry guys, cos theta was equal to the magnitude of x divided by the magnitude of our vector. So in order to solve for x, I'm just going to move the v, or vector, up there. So cos theta, magnitude of v. And then we'll sub in our values and just calculate it. So v is 200 kilometers per hour, cos of our 35 degrees. And when we calculate that, cos of 35, make sure your calculator is in degrees, and we get 163.8. So our horizontal component is 163.8 kilometers per hour. If we want to do our vertical, we'll just do the same thing, but this time we're going to find out what is y. And from our note, we get sine of theta is our y component, magnitude of y, divided by our vector. So we'll do the same thing. We're going to move this over, just like we did in our trigonometry unit. So I hope it's all coming back to you guys, because we just finished it. And we'll do 200 times sine of 35. And this one gives us 114.7. And that's kilometers per hour. So that's how you do it. If you want to then put directions on them, this one was going east and this one was going north. So do make sure you put the direction on there for the vertical component, and that you're specifying that it's north or south for your vertical and east or west for your horizontal. But that is essentially what you're doing. It's kind of like an extension of trigonometry. So if you liked trigonometry and you found you were okay with it, hopefully vectors is going to kind of look a little bit more familiar, but also kind of put some of that trigonometry into some more real life situations for you guys. That's it for this lesson. Have fun with the practice questions. Try a few of them out, and I'll see you in the next video.